So if you take the most abstract, notoriously unsolvable problem in pure mathematics, right, and you put it right next to the messy physical reality of quantum nuclear physics, they really shouldn't match.
No, not at all.
I mean, they belong to completely different universes of human thought, but back in 1972, they actually did match, like
Yeah.
down to the absolute millimeter.
Yeah.
So today, we're asking a fundamental question about how we perceive reality, which is, you know, when is a pattern a genuine miracle of the universe, and when is it just our brains lying to us?
It's kind of the ultimate epistemological trap, isn't it? Because our brains are, well, they're biological pattern recognition machines.
Right.
We're basically hardwired to impose order on chaos. And that means we constantly risk projecting our own internal narratives onto just random noise.
We see what we want to see.
Exactly. We end up convincing ourselves we found this profound truth when, really, we've just found a neat coincidence.
Which brings us to the mission of today's deep dive. We are unpacking this fascinating epistemological text that explores the razor-thin boundary between genuine mathematical discovery and what the source terms mathematical storytelling.
It's a great concept.
Yeah, we've got our stack of sources here, and the goal is to equip you, the listener, with an intellectual toolkit. We want to analyze how the greatest minds distinguish a universe-altering miracle from a manufactured myth.
So you could apply that exact same filter to the information you consume every day.
Exactly.
And to build that toolkit, we really have to examine the anatomy of a true miracle. The text anchors this whole exploration in a legendary encounter.
Oh, this is such a good story.
Right. It took place at the Institute for Advanced Study in Princeton. It's 1972. And this brilliant number theorist named Hugh Montgomery is just having tea.
Just a casual afternoon tea.
Just having tea. And he strikes up a conversation with the eminent physicist Freeman Dyson.
Okay, let's unpack this a bit. Because to really grasp why this tea time chat is treated like an intellectual earthquake, we have to understand what these two men were actually doing before they sat down.
Right. They were in totally different worlds.
Completely isolated mountains of human knowledge. So Montgomery was tackling the Riemann hypothesis, which is, I mean, it's essentially the holy grail of pure mathematics.
It's a big one.
Yeah, it deals with prime numbers. And prime numbers are infuriating because they're the fundamental building blocks of all integers, yet they just appear to pop up completely randomly along the number line.
Like there's no obvious rhythm to them at all.
Right, exactly.
But back in the 19th century, Bernhard Riemann proposed that the secret distribution of prime numbers is actually controlled by the behavior of this highly complex landscape called the Riemann zeta function.
Which sounds intimidating, but it's just a mathematical function.
Right, and specifically, Riemann pointed to the zeros of this function. So the exact points where the function's value drops to zero. If you can understand the spacing and the distribution of those zeros, you essentially unlock the hidden architecture of the prime numbers.
Wow.
So Montgomery was trying to figure out the probability of finding one of these zeros a certain distance from another zero. This is known mathematically as their pair correlation.
So Montgomery's looking at the ultimate abstraction, like the genetic code of numbers.
Yeah.
Dyson, on the other hand, is a physicist dealing with the gritty reality of atomic energy. He'd been working on quantum mechanics, specifically the behavior of heavy atomic nuclei.
Right, like uranium. And in quantum mechanics, especially with heavy nuclei, the systems are just so incredibly complex that you can't simply calculate the exact energy state of every single proton and neutron.
It's just too much.
It is computationally impossible. So physicists like Eugene Wigner and Freeman Dyson developed something called random matrix theory.
Which I always think of random matrix theory like trying to understand a massive swarm of bees.
Oh, I like that.
Because you have absolutely no chance of predicting the exact flight path of one specific bee in the middle of all that chaos.
Right, there are too many variables.
But if you use a matrix of probabilities, you can accurately predict the statistical shape, the density, and the overall behavior of the entire swarm.
That is a brilliant way to visualize it.
Mm.
So Dyson was working with a specific type of probability matrix called the Gaussian Unitary Ensemble, or the GUE.
The GU, right.
He used the GUE to predict the spacing between the energy levels in these heavy nuclei. And what he found was this phenomenon called level repulsion.
Level repulsion, meaning they push away from each other.
Exactly. The quantum energy levels do not like to sit right on top of each other. They repel each other, maintaining a very specific statistical distance.
Interesting.
And Dyson worked out the exact mathematical formula for that repulsion.
Which brings us back to tea time.
Yes.
So Montgomery casually mentions the highly specific, incredibly dense mathematical formula he just derived for the repulsion between the zeros of the Riemann-Zeta function.
And Dyson just stops dead.
He recognizes the equation immediately.
Because it's his equation.
Right. The formula Montgomery derived for the spacing of abstract prime number zeros is the exact same formula Dyson derived a decade earlier for the spacing of quantum energy levels.
The sheer improbability of that convergence is just staggering. Dyson referred to it as a miracle.
But not like magic.
No. In the context of our sources, he isn't using that word to imply supernatural intervention. He's defining a highly specific epistemological event.
A miracle of knowledge.
Right. A true miracle, in this framework, is an independent derivation from first principles.
They started from completely different axioms.
Completely different.
Like one is looking at the fundamental building blocks of numbers, and the other is looking at the energy levels of atomic nuclei.
Precisely. They were working with entirely different rule sets, different disciplines, different physical realities. Yet, the underlying structural mechanism they uncovered was identical.
It's like two people start digging a tunnel from opposite sides of the planet using completely different maps.
One in French, one in Swahili.
Exactly. And they end up meeting precisely in the middle, down to the millimeter. You can't just write that off as a fluke.
You really can't. I'll actually quote Dyson directly from the text here because it perfectly captures his perspective.
Yeah.
He said, his result was the same as mine. They were coming from completely different directions, and you get the same answer.
Yeah.
He goes on to say, it shows that there is a lot there that we don't understand, and when we do understand it, it will probably be obvious. But at the moment, it is just a miracle.
Coming from completely different directions, it implies a shared hidden architecture beneath both disciplines.
Absolutely.
But I think we really need to define the boundaries of this miracle because, people claim to find shared architectures in nature all the time.
Oh, sure.
Like we all know the famous Nautilus shell example.
Right, the golden spiral.
Yeah, people constantly claim its spiral perfectly embodies the golden ratio, that 1.618 number. We also know that's a debunked mathematical myth.
Completely debunked.
The ratio of a Nautilus shell is typically about 1.33. It doesn't actually fit.
Not at all.
But what fascinates me is why our brains, and honestly often highly intelligent researchers, so desperately want to round up and force these patterns to fit. Why is a quantum prime connection so much more legitimate than spotting a spiral in a seashell?
Well, you've hit on the exact mechanism of a mathematical myth there, which the text explicitly contrasts against the Dyson-Montgomery miracle.
Okay.
The danger really lies in our psychological vulnerability to confirmation bias. The text cites mathematician George Markowski, who's written extensively on how the golden ratio myth propagates.
Oh, I've read some of his stuff.
Yeah, he points out that when humans desperately want the universe to possess a kind of poetic symmetry, we start with our desired conclusion.
We start with the golden ratio.
Exactly. And then we actively hunt for data that confirms it.
And when the data doesn't perfectly fit, like the 1.33 Nautilus shell, we just squint a little harder, ignore the precise measurements, and call it an approximation.
We retrofit the evidence to save the narrative.
Right.
Which is the absolute hallmark of mathematical storytelling. You're drawing the bullseye after the arrow has already hit the wall.
That's a great way to put it.
A myth survives on selective, cherry-picked data and approximate fits. But the Dyson-Montgomery connection was fundamentally different.
Because of the precision.
Right. We're talking about uncompromising quantitative precision. Montgomery's pair correlation function didn't kind of look like Dyson's GUE distribution if you smoothed out the edges.
It wasn't an approximation.
No, it matched its precise, complex mathematical form identically.
Okay, so exact quantitative precision is our first major filter. If someone presents a pattern that requires you to ignore outliers or accept close enough measurements, you are likely looking at a myth.
Exactly.
But let me push back on the Dyson-Montgomery connection for a second.
Sure.
If this connection between prime numbers and quantum physics is so undeniably perfect, why hasn't it solved the Riemann hypothesis yet?
That's the big question.
Because mathematicians can be easily fooled by the law of small numbers, right? Like patterns that look flawless for the first 1,000 or million iterations, but completely fall apart when you reach a billion.
Oh, it happens all the time.
Right. So are we sure this isn't just a highly sophisticated, high-level version of the golden ratio myth that just hasn't broken yet?
Well, that is exactly the kind of rigorous skepticism the scientific community applied to this discovery. And it leads to the second, really most crucial criterion for distinguishing a miracle from a myth:
Because
falsifiability and survival under extreme stress testing. A myth crumbles under increased scrutiny.
right, when you measure 1,000 Nautilus shells with calipers, the golden ratio illusion evaporates.
Exactly. But true mathematical miracles welcome the scrutiny. Following that tea time meeting, mathematicians didn't just accept the connection as a neat parlor trick. They spent the next decade trying to break it.
Because if confirmation bias is the disease, extreme computational stress testing is the cure.
Yes,
You can't fudge the numbers when you push the mathematics to its absolute limit.
precisely. And a researcher named Andrew Odlyzko took up this exact challenge in the late 1980s.
Oh, Lisco, right.
He utilized immense computational power to calculate the zeros of the Riemann zeta function. But he didn't look at the early small numbers where coincidences often hide.
Where'd he look?
He jumped to the incredibly massive scale of 10 to the 20th power. That's a 1 followed by 20 zeros.
Just to put that in perspective for you listening, 10 to the 20th is on the scale of the number of grains of sand on Earth.
It's almost unfathomable.
It is a staggeringly vast mathematical territory.
And in that distant territory, Odlyzko computed the exact positions of 8 million consecutive zeros of the Riemann zeta function.
8 million of them.
Yes. He was explicitly looking to see if the statistical spacing of those zeros still mirrored the quantum energy level repulsion of the GE distribution.
So this is the stress test.
This is it. If the tea-time miracle was just a low-number coincidence, this is where the tunnel would collapse.
But the tunnel didn't collapse.
No, it didn't.
When he pushed the math to the extreme limit of 10 to the 20th power, the zeros aligned with the GUE distribution with even greater precision.
It didn't blur. It came into sharper focus.
Wow.
It became undeniable.
Hmm.
What's fascinating here is Odlyzko's computations confirmed the connection numerically with a level of exactness that completely eliminates the possibility of human imposition or confirmation bias.
The math was just speaking for itself.
Exactly. But to address your pushback regarding why this hasn't solved the Riemann hypothesis yet,
Right, because it's still unsolved today.
it is. And that brings us to the third defining characteristic of a true miracle, which is explanatory depth.
Okay, explanatory depth. Because if it was just a dead end, it wouldn't be very useful.
Right.
A myth just sits there looking pretty. It doesn't actually teach you anything new about how the universe operates.
Exactly. A myth is just a superficial description. But a miracle reveals a structural mechanism and generates entirely new avenues of research. So the GU connection didn't solve the Riemann hypothesis overnight, but it provided a concrete framework for how a solution might eventually work.
It pointed them in the right direction.
Yes. Building on this exactness, Dyson later proposed that if the Riemann hypothesis is true, the zeros of the zeta function must form something called a one-dimensional quasicrystal.
Okay, let's unpack one-dimensional quasicrystal because that sounds like literal science fiction.
It does sound a bit sci-fi.
So a standard crystal, like a diamond or salt, has a perfectly repeating periodic structure. You look at one tiny section and you know exactly what the rest of the crystal looks like forever.
Right, it's totally predictable.
But a quasicrystal is different. It's highly ordered and structured, but it never repeats itself in exactly the same way. It has rules, but no simple periodicity.
That is an excellent description. Now, what Dyson proposed was that the arrangement of the Riemann zeros forms this non-repeating, yet strictly ordered quasicrystal structure.
Okay.
And here is where the explanatory depth truly shines. Mathematicians realized that if you take this theoretical quasicrystal and apply a specific mathematical operation to it,
Known as a Fourier transform, right?
yes, the Fourier transform, something extraordinary happens.
The Fourier transform acts essentially like a prism. Like if you shine complex white light through a prism, it breaks it apart into its constituent pure colors.
Exactly.
Or, to use an audio analogy, it's like having a chaotic audio recording of a crowded room, and the Fourier transform acts like a highly tuned radio dial that isolates the exact frequencies of just one specific voice.
Yes, it isolates the underlying frequencies. And when you apply that Fourier transform to the frequencies of the zeta-zero quadricrystal, the output it generates corresponds exactly to the logarithms of the prime numbers.
Wait, really?
Yes, exactly to the primes.
That is incredible. So you take this abstract, infinitely complex quantum structure, you run it through a mathematical prism, and it just spits out the locations of the primes.
It does.
It takes what looks like the chaotic static of prime numbers and reveals the hidden blueprint governing them.
It provides a why and a how. It demonstrates that the prime numbers aren't just random accidents on the number line. They are the inevitable structural consequence of this deeper quasi-crystal geometry.
Oh, wow.
That is what separates a profound discovery from mathematical storytelling. It opens up an entirely new universe of falsifiable, testable research.
Which perfectly transitions to the so what of this entire deep
The
dive.
practical application.
Right. So what does this all mean for you? Because you listening right now are probably not computing 8 million zeros of the Riemann zeta function today.
Probably not.
But you are constantly bombarded by information. Every day, algorithms, media outlets, pundits, they hand you patterns.
totally.
They claim to have found the secret trend in the stock market or the hidden geopolitical conspiracy or, the perfect diet based on ancient DNA.
Oh, the die ones are everywhere.
Right. So how do we take this incredibly rigorous mathematical standard and apply it to the noise of everyday life?
Well, the core lesson the sources impart is the absolute necessity of epistemological humility.
Humility.
Yes. Look at how Freeman Dyson reacted to uncovering one of the most profound mathematical connections of the 20th century. He didn't call a press conference and claim he had unlocked the secrets of the universe.
He didn't write a best-selling pop science book that week.
No, he recognized the profound limits of his own knowledge.
He explicitly said, at the moment, it is just a miracle. He knew they had found the door, but they didn't have the key to open it yet.
Exactly. He maintained an objective distance from his own discovery. He proposed a concrete research program to understand the connection, but he cautioned that the work would be grueling.
He wasn't going to be a quick fix.
Not at all. He noted it would likely be as, quote, horrendously difficult as the problems that mathematician Andrew Wiles tackled.
And Andrew Wiles spent 7 relentless, isolated years grinding away at Fermat's last theorem before he finally cracked it.
Right. Real discovery requires exhausting, methodical labor.
It is the exact opposite of a quick viral claim that promises to explain everything simply.
And that is the filter we must apply to the information we consume. When someone presents you with a compelling pattern that perfectly explains a complex issue, you have to ask yourself a few things.
Like what?
Does this idea generate falsifiable predictions? Can it be tested and potentially proven wrong by new data? Or does it rely on confirmation bias, conveniently explaining away any counter-evidence as just an anomaly?
Does it survive extreme stress testing, or does it get fuzzier the closer you look?
Exactly.
If an idea requires you to constantly squint and ignore outliers to make it work, it's a myth.
It's mathematical storytelling.
But if it perfectly aligns without any forced manipulation, and more importantly, if it opens up new, unexpected pathways of understanding, you might actually be looking at a genuine truth.
It is a demanding standard, definitely. But the alternative is living in a world of illusion, constantly being manipulated by narratives that only look true from a distance. The Dyson-Montgomery meeting is really a masterclass in demanding more from the patterns we accept into our worldview.
So let's consolidate this toolkit.
Let's do it.
We've established that a myth relies on retroactive imposition, right? Starting with the answer you want and forcing the data to fit.
Right.
It relies on approximate measurements, like the 1.33 Nautilus shell,
Yeah.
and it survives purely by ignoring contradictory evidence.
That's the myth.
Conversely, a true miracle is defined by independent convergence from completely different first principles. It demands exact quantitative precision.
Precision is key.
It survives rigorous falsification, holding up even at the scale of 10 to the 20th power. And crucially, it possesses explanatory depth, offering a structural mechanism that pushes human knowledge forward rather than just reinforcing what we already want to believe.
Applying those criteria is exactly how you separate the signal from the noise in a very chaotic world.
It is a profound standard, and it leaves us with one final, deeply philosophical question to mull over.
Oh, I like where this is going.
We began by acknowledging that human brains are biological pattern recognition machines, desperate to impose order. But when you look at a genuine mathematical miracle, when you see that the abstract, infinite distribution of prime numbers flawlessly, effortlessly mirrors the physical repulsion of quantum nuclear energy levels without any human design or intervention.
Yeah.
Does that mean mathematics is merely a language we humans invented to describe the world, or is mathematics the actual physical blueprint of the universe itself, an objective underlying reality that we are just stumbling around in the dark, slowly discovering?
It's the ultimate question.
Next time you see a pattern, ask yourself, did that pattern naturally emerge from the deep architecture of the universe, or did you impose it there just to make the chaos feel a little more comfortable?